Betelgeuse makes the sun look old in every respect. Located in the constellation Orion, the red supergiant has up to 1,000 times the diameter, 10,000 times the luminosity, and almost 20 times the mass of our host star. And yet, it's not only its incredible dimensions that make it the focus of astronomical interest. One day, Betelgeuse will explode as a gigantic supernova and treat us to a dazzling spectacle that will even be visible in daylight. In recent years, however, the star has surprised researchers even more, and its irregular fluctuations in brightness, inexplicable pulsations, and unusually high rotational speed are raising new questions. But then, astronomers made an astonishing discovery. New observations show that Betelgeuse is not alone. It has a previously hidden companion that influences its behavior and provides a solution to a series of exciting puzzles. So, be sure to stay tuned until the end to find out what secrets Betelgeuse and its partner star really hide. Betelgeuse has been keeping experts on tenterhooks for decades now, and researchers are repeatedly confronted with phenomena that are not so easy to explain. Basically, the shoulder star of Orion is subject to recurring fluctuations in brightness that extend over different periods of time. In detail, this means that in addition to short pulsations, longer changes in brightness occur, which have long puzzled scientists. However, starting in October 2019, there was a much more dramatic drop in brightness, which immediately fueled the most exciting theories. For a better understanding, however, a brief explanation is in order. In astronomy, magnitude or mag for short indicates the apparent brightness of a star. The principle is that the smaller the value, the brighter the object appears to us. And while Betelgeuse with an average brightness of 0.58 mag is usually one of the brightest stars in the night sky, its value dropped to 1.61 mag at that time. As a result, it was outshone by 20 other stars. And the crucial question, of course, was what on earth was responsible for this? Some researchers saw this as a harbinger of a cataclysmic event that Betelgeuse is heading for anyway. As a red supergiant, it is in the final stage of its stellar life and will inevitably explode in a gigantic supernova. And the following shows what that means in concrete terms. While Betelgeuse is already 10,000 times brighter than the Sun, its luminosity will then increase another 16,000 times. In the process, it could even reach an absolute brightness of up to -8 mag, making it as bright as a full moon and easily visible even during the day. But as we know, this is still a cosmic pipe dream. The drop in brightness a few years ago was not related to a supernova, but to a huge cloud of dust that Betelgeuse itself had ejected. The material enveloped the star and temporarily darkened it before its apparent brightness returned to its average value at the end of April 2020. The rotation puzzle is Betelgeuse rotating too fast. Another mystery that the stellar giant poses for scientists concerns its rotational speed. Measurements taken with radio telescopes have shown that the red supergiant rotates at about 15 kilometers per second, significantly faster than our model predict for stars of this size and age. Massive stars usually slow down as soon as they swell into supergiants, as their enormous diameter and loss of mass slow down their rotation. However, Betelgeuse turns this common pattern on its head. Or does it? Well, that is precisely the question that needs to be answered. On the one hand, it's possible that the supergiant once swallowed a smaller companion star, which transferred its angular momentum to the outer shell of Betelgeuse, and on the other hand, that we are victims of a cosmic mirage. In fact, the astonishingly high rotational speed could also be an optical illusion. The surface of Betelgeuse is covered with huge bubbling plasma bubbles known as convection cells, which carry heat and matter from the inner layers to the outside. These intense movements create local currents and shifts in the star's atmosphere, which alter the light we measure from Earth. When observed, it may then appear as if the star is rotating faster overall, even though this is not the case. In other words, we will not necessarily see the rotation of the entire celestial body, but only the chaotic movements on its surface which distort the measurement results. However, it is not yet clear which of the two scenarios applies. What has been clarified in the meantime, however, is that Betelgeuse has been hiding a secret from us for centuries and is not alone after all. How the researchers discovered Betelbuddy. To understand how the experts tracked down Betelgeuse's companion, we need to briefly recall the recurring changes in brightness. In addition to the well-known short pulsations with a period of about 400 days, there are also subtle brightness fluctuations with a 6-year rhythm for which there was no valid explanation for a long time. Then, however, researchers at the Flatiron Institute in New York discovered that the observed fluctuations perfectly match a partner star weighing about 1.7 solar masses, which orbits a supergiant closely. But why? And this is a crucial question. Did this stellar companion escape our attention for so long? After all, we haven't just been observing Betelgeuse since yesterday. It is even described in ancient writings. Well, the fact that a companion has been able to elude our gaze for so long is simply due to the extreme inequality of the stellar duo. In other words, the much larger Betelgeuse significantly outshines its partner, and its close orbit of only 2.4 Betelgeuse radii does the rest to complement direct observation. Despite all the differences in size and mass, the companion's effects on the system are still noticeable. When it's behind Betelgeuse, as seen from Earth, the secondary period falls to its lowest brightness when the stars are next to each other. However, the combined brightness reaches its maximum. But that's not all. In addition, the companion could also influence the dust clouds around Betelgeuse, further amplifying the periodic flashing and dimming. But while all this sounded extremely plausible in theory, it was still necessary to confirm the existence of the companion star beyond doubt. And that is exactly what astronomers succeeded in doing a few months ago. The images taken with the speckle imager at the Gemini North Telescope in Hawaii provided the first direct images of the tranquil companion, leaving no doubt that it really exists. Since then, the companion has become known as Betel Body, even though that's not its official name. Its official name is Sawara, and that is no coincidence. While the Arabic name for Betelgeuse means hand of the giantess, Sa means nothing other than her bracelet. However, experts are not only richer in a fitting name and groundbreaking images, but also in a series of exciting findings. The study suggested that Sawara weighs about 1.5 solar masses and glows bluish-white, which is simply because at around 10 million years old, it's still a young star whose nuclear fusion has only just begun in earnest. But although Sarah is still in its stellar youth, its days are already numbered. However, its fate is not sealed because of the future supernova of Betelgeuse, but because of its close orbit, which is gradually narrowing and bringing Sa closer and closer to Betelgeuse. According to estimates, it could come so close to Betelgeuse in the next 10,000 years that it will be torn apart by its extreme tidal forces. And while 10,000 years are nothing more than a fleeting blink of an eye in the cosmic context, it's enough time for us to take a close look at SAR. Astronomers recently did just that with the help of the Chandra X-ray telescope and Hubble's UV camera. This confirmed what had already been suspected, that Sarah is not a white dwarf or neutron star, but a so-called young stellar object. Furthermore, the results underscored the extreme inequality of the binary star system. The tiny partner is evolving much more slowly. In the course of the latest investigations, the mass estimates were revised downward once again. Sa probably weighs less than 1.1 solar masses. Betelgeuse, on the other hand, is up to 19 times more massive than our source of heat and life. Sarah is thus growing up, so to speak, in the shadow of the imposing supergiant and is even still in its original cocoon of gas and dust, while its oversized counterpart is heading for its thunderous finale. And the question that's burning in the minds of professional researchers and enthusiastic amateurs alike is, of course, when exactly Betelgeuse will make its explosive departure. The answer, however, is that we simply cannot predict this with any precision. In principle, however, it can be assumed that from a cosmic perspective, the star will soon turn into a supernova. Whether this will happen in 1,000, 10,000, or 100,000 years cannot be narrowed down any further at this point. The internal fusion processes of the red supergiant are complex and unstable, and the mass of stellar winds, rotation, and convection are constantly changing its structure. There is no reliable precursors to the final explosion. All we know for sure is that one day the stellar colossus will become a dazzling celestial firework display and could turn night into day. And you can now easily subscribe with just one click. Press the thumbs up button and subscribe so you never miss a new video from us again. See you soon.